are back to chapter 10, section 6 this time. We're doing secants, tangents, and angle measures. We learned what a tangent was already. Now we need to learn what a secant is. What is a secant? We will find out. A secant is a line that intersects a circle in exactly, remember that word exactly means only 2 points. A line, picture it, a line that intersects a circle in exactly 2 points. It's always good to try to draw these things out so you can see what they look like. Oops. A secant of a circle contains a chord. Remember, a chord goes through the circle and it has both endpoints on the circle. So let's see what this is going to look like. And why does that keep coming up? Okay, so here's our circle. This would be a secant. It goes through the circle and it intersects the circle at 2 points, one here and one here. Okay, so that's the chord that it contains. So now you have an idea of what a secant looks like. Do you remember what a tangent was? A tangent, remember, touched the circle at just 1 point. So it would have been totally on the outside of the circle, touching like right here. But a secant goes through the circle. Know the difference between those two terms. So we have a tangent chord theorem. Now, remember, a secant contains a chord. So I'm going to use those terms interchangeably here, chord and secant. I know that they don't mean the same thing, but because the secant contains a chord, if it's true for the secant, it's going to be true for the chord as well. So here's what this theorem says. If a tangent and a chord intersect at a point on the circle, so they're both touching the circle at the same point, then the measure of each angle formed is half of its intercepted arc. Again, I know these are kind of wordy theorems, but if you would picture it as you're saying it, try to draw it, that'll help you understand what these words mean. Okay, so here's a picture. We have a circle, and on this circle we have a tangent touching it at 1 point. What name of the point is it touching? It's touching here at B. And then we have a secant coming through the circle. It's also touching the circle at the same point, point B. So that's what this definition means up here when it says, you know, a tangent and a chord intersect at a point on the circle. Here they are intersecting at that point on the circle. Then the measure of each angle formed. Okay, so here's an angle ABC. Here's another angle DBC. Those are both angles created by that intersection. Their measure is going to be half of the intercepted arc. Well, remember what that term means, intercepted arc? It's the arc that is cut, in a sense, by the two sides of that angle. So if we extend the sides out, this red part is the intercepted arc of angle ABC. So whatever its measure is, we're going to take half of that, and that's going to be the measure of this angle. So if this arc was 100, then angle ABC would be 50. If this arc was 60, then the angle of ABC would be 30, and so on. And same thing over here. Arc BEC is the intercepted arc of angle DBC. So this angle here is going to be half of the measure of this arc. So let's look at a real simple example here. Okay, here's a circle. It has a chord. Remember, It's also like a secant. If this were to go on forever, it'd still be a secant, but same kind of picture here. Intersecting a tangent at a point on the circle. So we created two angles, x and y. The measure of angle x is going to be half of this intercepted arc here. So if the intercepted arc is 100, what is the measure of this angle going to be? Okay, so hopefully you said 50 because that's half of 100. Okay, so half of 100 is 50. Now, how are we going to find the measure of angle y here? Remember, a circle has how many degrees in it all the way around? 360. So if we know that this portion here is 100, what would be left around the other side? 360 minus 100, right? Which is 260. So then we would take half of 260 and we get 130. So over here we get 130. And this is 50. What's a way we could check ourselves to make sure that we got the right degree measures here? We know that together, angle y and angle x make this straight line that we are calling a tangent. So if two adjacent angles, two angles attached to each other, side by side, are creating this straight line here, how many degrees should they make when we add them up? They should make 180. Is 130 plus 50 180? Yes, it is. In fact, that's another approach you could have taken to find angle y. You could have said, okay, well, angle x is 50. I know that together they have to make 180, therefore this one had to be 130. So as I always say in geometry, the more rules you learn, the more options you have for approaching a problem. So now let's use what we know here to solve this problem. They're asking us to find angle RPS. Well, first you got to identify the angle you're looking for. Make sure you're finding the right one. And we know that these arcs, PT are 114 and TS is 136. Well, in order to find this missing angle that they're asking us to find, we have to know the arc length of the intercepted arc here. And we don't have that. So then we have to ask ourselves, how am I going to find it with what I know? I know that a circle is a 360 degrees. So if I add up these two parts that we already know, I get 250. So if the whole thing is 360, how much is left? So this arc over here is 110. Okay, so here it is nice and neat. So we're going to add, we added the two together that we know right here. And we're going to subtract those from the whole circle, which is 360. So we get 110. Now we know that the angle that we're looking for right here is going to be half of this arc. So if the arc is 110, it's going to be half of that 110, or 55. Okay, let's do another one. Same exact situation. We're given these two arcs over here, but we're actually looking for the angle on the other side of the circle. So therefore, we've got to find this arc first. So we're going to add these two arcs together. 164 plus 80. 244. Now I'm going to subtract that from 360. I get 116, and then I need to take half of that. Okay, notice they put 116 in here. So the correct answer is in there, but so is the answer of you making a mistake. Correct answer is 58. Okay, we also had a theorem involving two chords, or again, two secants. Remember that it's the same relationship for these situations. So we've got two chords going through the circle. If they intersect inside the circle, so it makes like an X, okay, so again, try to picture it, then the measure of the angle formed is half of the sum of the arcs intersected by the angle and its vertical angle. So you need to know these terms that we learned way back at the beginning of the school year. So here's what it looks like. Okay, so we have two secants going through the circle. Their intersection is inside that circle. Okay, we're going to deal with intersections in different places here in this video. So this one is intersection inside the circle. So if we're looking for angle 1, we got to add up arc AC and DB, because it says the sum, and then we got to take half of that. So we're adding them up and dividing by 2, and that would help us find angle 1. If we want to find angle 2, then we've got to take the sum of AD and CB and divide them by 2. So let's do a real simple one. Okay, and I kind of remember that we add by the fact that this kind of looks like a plus sign, kind of, sort of. So we have a 100-degree arc here, a 40-degree arc on the other side. Remember, it has to be the arcs of the vertical angles. They have to be across from each other. They can't be next to each other. It's the arcs across from each other. You add them up and divide by 2. So 100 plus 40 is 140. Half of that is 70. Okay, now what if we wanted to find the one next to that? Notice that these are adjacent angles. If I called this Y, angle Y, X and Y are adjacent angles that make a straight line, so therefore they must add up to how many degrees? 180. So I could just subtract here and know that angle Y is 110 degrees. And so would its vertical angle. So by knowing one, we can fill in all 4. Remember, vertical angles are congruent. Okay, let's do one here, just like the one we just did. So I'm going to add the 2 arcs. Remember, they have to be across from each other. So I'm going to add the 2 arcs, FG here and EH, and then I'm going to divide by 2. So 88 plus 76. You can use a calculator or you can use your head. 164, and then I'm going to divide that by 2. 2 goes into 16 8 times, nothing left over. 2 goes into 4 2 times, so 82. So now that's the measure of angle 3. Angle 4 is going to be 180 minus angle 3. So 180 minus 82. What are you going to get before I show you the answer? You know, sometimes it'd help for you to have a calculator next to you while you're watching these videos so you know where my numbers come from. You can check me, make sure I'm not making a mistake. And it's hard to see there through my scribble, but 98 is the correct answer. Okay, or you could have done it this way. 2 different ways we could have approached this problem. We could have found the sum of these two. Since we were looking for angle 4, we really need the sum of these 2 arcs that are unknown and divide it by 2. Well, I can't find the individual measures of those arcs, but I can find their sum, because the sum of these 2 arcs is what's left over when I add these 2 arcs together and subtract from 360. So that's what we're going to do. We're going to add the 2 that we know here and then subtract that sum from our 360. Well, when I add 88 and 76 together, I get 164. When I subtract that from 360, I get 196. Now, I need half of that to get my angle measure. Okay, so angle 4 here is going to equal half of the sum of these two arcs. Well, the sum of those two arcs was 196, so 98. Notice I get the same answer either way. So whichever way you like better. And personally, I think it's a lot easier to find this one and then subtract from 180. But to each his own. Okay, so let's figure this one out. They didn't mark up our drawing, so we need to mark up our drawing based on what it says in the description. Remember to always read your description and mark up your drawing. They're actually asking us to find angle 5, so read carefully. So I'm going to find angle 6 first by adding my two arcs. And then what? Divide by 2. Whoops, 42. Is that the answer? It's there. So you're going to be tempted to do that, but no. That's this angle. They're asking us for angle 5. So then what do we do to find angle 5 if we know angle 6 is 42 degrees? We're going to subtract it from 180 and get 138, which is answer D. And there you go. Okay, last theorem, I believe, is the two-line theorem. It says if two lines intersect on the exterior, what does exterior mean? Okay, so if two lines intersect on the outside, so here's our circle, we got a point outside, we got two lines intersecting outside there, then the measure of the angle formed is half of the difference. This time we're going to subtract. So in all three theorems, we're taking half. But in one, when the point was on the circle, we just took half, and that was it. When it was in the circle, we added, dang it, oh shoot. We added and divided by 2. And now if it's on the outside, we're going to subtract and divide by 2. But there's 3 different pictures we could draw here. The first one is if we have 2 secants. Remember, a secant goes through the circle. It touches at 2 points. So this is a picture of what 2 secants would look like. But still, notice their intersection is on the outside of the circle. We can also have a secant and a tangent. Okay, so here is a secant going through the circle, a tangent touching at just 1 point. But both have the intersection on the outside. So again, we're going to do the same thing. We're subtracting the 2 arcs and dividing by 2. So here's my 2 arcs. Subtract them, divide by 2. Okay, and then the third situation is that we can have 2 tangents that just go along the outside. Okay, it's still creating 2 arcs though. So in all 3 situations, the intersection's on the outside. We're going to subtract the 2 arcs and divide by 2. Okay, so let's look at a real example. Is the intersection on the outside? Yes. All we care about is it on, inside, or outside? It really doesn't matter if it's a secant and a tangent, or a tangent and a tangent, or 2 secants. What matters is where the intersection is. Since it's on the outside, we are going to subtract the 2 arcs. So here we go. And we always want to subtract the small one from the big one. Put the big one first, because we can't have negative angle measures in these situations. So we want our answer to be positive. So 100 minus 40 is 60. We're going to take half of that, and we get 30. Okay, so it's pretty simple. You just have to remember when to add, when to subtract, and when to just divide by 2. Okay, so you're going to have to study a little bit. You're going to have to take it upon yourselves to commit that to memory. Here's a problem with a twist. Yes, we have an intersection on the outside. Yes, we have the two arcs and the angle. But this time, we're looking for one of the arcs. The angle's given to us. As long as we have two of the three numbers, we can work this problem. Okay, so we got to just think it through a little bit. We know that if we subtract these two, 141 minus x, and then divide it by 2, we will get our angle measure. So we can just put an equal sign here. So we're going to set our equation up like this. 62 is going to equal half of the difference of those two angles. So it would look something like this. Remember, you could have the 62 over here on this side, just like I drew it out over here. Okay, but now you got to remember your algebra. If I want to get rid of this half here, remember, this is like divided by 2. What's the opposite of dividing by 2? It would be multiplying by 2. So I need to multiply both sides by 2. That gets rid of this 1/2 here. So what I'm left with is 2 times 62, which is 124. And then whatever was left here in parentheses, because I just got rid of that 1/2. Okay, so again, think of opposites. If we're dividing here, we want to get rid of that. We got to multiply. Now it's just your basic algebra problem. We're going to add x to both sides so we have positive x. Then subtract our 124 from both sides and we get 17. Okay, so that's another way that this relationship could be used to find a missing part. It's not always going to be the angle you have to find. Sometimes it's going to be the arc you have to find. So you really have to understand the relationship and not just try to memorize a formula. Here's another one, very similar to what we just did, only this time it's the bigger arc that we're looking for. So again, we're going to say x minus 35, the big arc minus the little arc is going to equal this after we divide it by 2. So I'm going to write this out. 38 is going to equal 1/2 of my 2 arcs subtracted, with the bigger arc going first. So again, what are we going to do to get rid of this 1/2? We're going to multiply by 2. That gives me 76. My 2's cancel out, so 76 equals x minus 35. I add 35 to both sides. And x is going to equal 111. Answer C. Okay, here's a challenging one. There's only one number here, our angle measure. It says a jeweler wants to craft a pendant with the shape shown. Use the figure to determine the measure of the arc at the bottom of the pendant. So somehow I've got to find, excuse me, find this bottom arc here. How am I going to do that? Well, what do we usually call the part that we're looking for that we don't know its number? So we represent its number with a letter. We usually call it x. Okay. Well, we need both arcs. If I called the green part y, which I could use a different letter. The problem is I'd have 2 letters in my equation, and I can't solve it for a number if I have 2 different letters. I can't have an x and a y in one equation and solve for a number. So I have to call this green arc something other than y. It has to have x in it. It has to have the same letter. So let's think about this. What is the relationship between these 2 arcs? What did I just create when I drew both of them together? I created a circle. And a circle has how many degrees? 360. So this green part is the whole 360 degrees minus the x part. So that's what I'm going to call it. I'm going to call it 360 minus x. It's the whole circle minus this red part here. If I took away this red part, I would be left with the green arc. So now I'm just going to set up my equation the way I have been. I'm going to take the big arc minus the little arc, but I got to put this in parentheses, and divided by 2, and that's going to equal my 40 degrees. So here it is written out a little bit neater over here. 40 degrees. I'm taking my big arc x, subtracting my little arc, but I have to put this in parentheses because this negative, remember this is like a -1, that has to be distributed to both parts of that parentheses. Okay, so we're going to do that over here because my slide doesn't show that part. Okay, so this would be x minus 360. Negative times negative is a positive x. When I put these two x's together, I get 2x minus 360 because the negative sign goes with the 360. Okay, so that's what we're going to see here. 40 equals 1/2. I just brought these two things down. I distributed my -1. That gave me two x's that I could put together. They're both positive. So it became 2x, and then my 360 was still negative. Now, how am I going to get rid of this half? I'm going to multiply by 2. 40 times 2 is 80, and that got rid of my 1/2, so I'm just left with whatever was in my brackets. Now, if I add 360 to both sides, do I need to show you that? Add 360 to both sides. I get 440 equals 2x, divide by 2, and I get 220. So my bigger arc, now remember this is x, my bigger arc is 220. What if it had asked me for my smaller arc? Then I would have to do 360 minus the 220, and I get 140. Now remember, you can always check yourself, because if these two are added together, they should equal the whole circle, which is 360 degrees. And they did. Okay, so here's another one. Could be any of the three examples I showed you. Two sides of a fence to be built around a circular garden in a park are shown. Use the figure to determine the measure of angle A. So we're looking for this. Okay, so if I know this is 105, I need to know this big arc so I can subtract them and divide by 2 and find that angle. Well, if the whole circle is 360, then the missing part is going to be 360 minus 105. And so that's going to be 255. Is this big arc right here. So 255 minus 105 divided by 2 is 75. Answer A. Okay. So when you have two tangents, you're going to rely on that fact that a circle is 360 degrees all the way around. You can be given any one angle in this situation and find the other two, or I'm sorry, one number and find the other two. Okay, let's do one more. I know it's getting long, but I want to show you several examples so you can get it down. Okay, we have outside intersection, so we're going to subtract the 2. We're going to take the bigger arc minus the littler arc, divide it by 2, and that's going to equal our 60-degree angle. Okay, remember to always put the bigger one first. I'm going to get rid of this 1/2 by multiplying both sides by 2. So that's where this 124 comes from. Okay, we're able to cancel out our 2's here. If I subtract the 141, I get a negative x still over here. That's okay, because this becomes a negative 17. So if negative x equals negative 17, then positive x equals positive 17. I just change the sign of both of them. As long as I change the sign of everything, I'm good. Okay. Oops, let me go back and do this real quick. Okay, this one, you might see something like this. Probably not, but again, we're going to subtract the 2 arcs. Okay, this shouldn't throw you. You should know how to do the algebra here. We're going to divide them by 2 and make that equal to 37. So I'm going to multiply by 2 to get rid of that 1/2. Now this is 20x minus 8x. I'm just going to group my like terms here. Negative 26 minus 8 is going to equal 74. 20 minus 8 is 12x. Negative 26 and negative 8 is a negative 34 equals 74. I add my 34 to both sides. Remember, I'm trying to get x by itself. That gives me 108. If I divide by 12, divide by 12, what do you get? You have your calculator next to you. You should get 9. So x equals 9. Answer C. Okay, we're done. Ciao.